Hi friends, today we're talking about graphing rational functions. A rational function. Remember, the root word of rational is ratio, and all a ratio is a fraction, which means that these are functions that have the variable in the denominator of our fraction. So we've got to graph these guys because they come in many different forms. And here are the 5 steps you want to use to graph these. Pause the video, write these down. They may not make sense right now, but they will in a minute. And then we will slide this up once you've got that and pause and go ahead and write all of this down, and then let's put this into action. Okay, so first things first, we've got this function right here, f of x equals x to the third plus 3x squared over x squared plus 2x minus 3. First thing first on our rules is to factor. So we're going to factor this guy on the top. We can get rid of an x. That leaves us with x squared. Oh, actually, we can get rid of 2 x's. My bad. So that leaves us with x plus 3. Downstairs, we can factor this guy to be x. This tells us different signs, so plus, minus. Factors of 3 are 1 and 3. I need a plus and a minus. That gives us positive 2. So -1, positive 2. -1, positive 3, will give us a positive 2. Cancel out x plus 3. Okay, so we've factored this. This is the second step. We found a whole, and our whole is that we have canceled out x plus 3. What that means is we need to write down what would make x plus 3 equal 0. -3. That's the first part of our whole. To find the second part, we now have to enter it into our new function, because once we've canceled these out, we now have a new function. F of x equals x squared over x minus 1. So what we're going to do is plug that -3 into this new function here. When we do that, we get -3 squared. Use your parentheses because otherwise it means something different. -3 minus 1. So it looks like we get 9 over -4. So -9 over 4, which is really -2 and 1/4, -2 and 1/4. I like to put it into a mixed number when I'm graphing. So we found a whole. That's what it means to find a whole. If you cross something out, you need to figure out what would make that 0 and then plug that into your new equation. So let's just be clear. Our new function is x squared over x minus 1. All right, that was number 2 was our find your holes. Number 3 is to find our x and y intercepts. X, y, I'm going to just start an xy chart here. First things first, I'm going to say x, and so f of x, fancy way of saying y. So if I plug in 0 for x, I get 0 out because I would have 0 over 0 minus 1, which gives me 0 over -1, which doesn't even matter what I have on the bottom. It is 0. If I plug in 0 for y, I would get 0 equals x squared over x minus 1. Multiply both sides by x minus 1, and it doesn't even matter because that's just times 0. So we get 0 equals x squared, square root both sides, we get x equals 0. So when y is 0, x is 0, vice versa. So we found our intercepts. All right, good. Now the next part that we have to do is our vertical asymptote, our VA. So this was our intercepts, 3. So 4 is going to be our vertical asymptote. Now your vertical asymptote is what will make your denominator equal 0, because we can never divide by 0. So if you take a look at our function here, and I feel like I need to highlight this so that, because I'm kind of all over the place when I'm writing this down. Take a look at your function here. What makes this denominator 0? +1. So let's say, for example, by the way, if you have something, side work, let's say you have your denominator is like 3x minus 1. And you're like, I have no idea what would make that 0. Set it equal to 0. Add 1 to both sides, we get 3x equals 1. Divide both sides by 3, we get x equals 1/3. And now you know, okay, if x is 1/3, then I get a 0. So that's a little pro tip. But in this case, it's fairly easy. If we set x equal to 1, we will end up with 0 in the denominator, which is not something we can have. So for our vertical asymptote, we always write that as x equals. It's the equation of a line. So x equals 1. That's usually the easy one because you just look at your denominator, what would make it 0, bam. Sometimes there's more than 1, that's fine too. For number 5, it is our horizontal asymptote, and this one can be a little bit tricky. So for our horizontal asymptote, you take a look at the first part of our function. If your exponent is larger on the top, there's no horizontal asymptote, and we're going to check for a slant. If it's larger on the bottom, your horizontal asymptote is x equals y. If they equal each other, you take these two leading coefficients and stack them. Regardless, it's always going to be y equals. So y equals. All right, so we look at this, y equals. Now we look at these guys, and here's our equation. This is x squared on the top and x to the 1 power on the bottom. So the top is larger. So if our top is larger, we have no horizontal asymptote, but we're going to check for a slant. So our horizontal asymptote, we don't have one, which means we need to check for our slant asymptote. So to check for our slant asymptote, where did our, this is why I highlighted it, otherwise I'm going to miss it. So slant asymptote, here's what we do. We take, remember that long division we learned earlier in this unit? You're going to do the same thing here. This is on top of the table, so we're going to put it under the table, x squared. And we're going to put x minus 1. Now we have to hold a placeholder in here, so I'm going to do plus 0x plus 0. What do I need to multiply x by to get x squared? Just x. X times x gives me x squared. X times that gives me negative 1x. Change my signs, add, and we get 1x, and then bring down plus 0. What do I need to multiply x by to get x is positive 1. 1 times that is x, 1x. This times this is negative 1. I'm going to change my signs. I have a remainder of positive 1. I don't care about the remainder. So technically you would write it as positive 1 over x minus 1, or x minus 1. But I actually don't really care about that right now. What I do care about is this guy right here, x plus 1. That is actually my horizontal asymptote. So not my horizontal. Let's try that again. It is my slant asymptote. So our slant asymptote is x plus 1. So y equals x plus 1 is my slant. Let's take all of this information now and we are going to graph it. So first things first, we are going to look for our hole, which again was at -3, -2.25. So let me find a good marker. It's like my never-ending problem is trying to find a good marker. So our hole is at -3, -2.25. So over -3, down -2.25. So it's like right there. I put a little open spot as much as I can. I don't have a fine tip marker there. So then our next part that we've got is our vertical asymptote is at x equals 1. And remember, we write that as an equation of the line because it is a line. We just do a little dash bit. Bam, bam, bam. Okay, the next part is that we do no horizontal asymptote, but we do have a slant asymptote. And remember, our slant asymptote was y equals x plus 1. That's just a line. We're going to graph that by starting at 1. We rise up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1, down 1 over 1. It's right there. I'm not right on my hole there. The hole is right there. Just like this. So our slant asymptote looks like this. Okay. So now the other part of this was our intercepts. We know it goes through 0, 0. So now our graph is actually starting to take shape. We know it's going to probably look something like this along here, and then something like this along here. At this point, what you want to do is just plug and chug. So for my XY chart, like if I did -1, what would I get? If I did -2, what would I get? So I'm going to swap back over here. I'm going to say, okay, let's do -1 and -2. So if I plug that in, I get y equals -1 squared, and then we do -1 minus 1. So that's going to give us 1 over -2. That is -1/2. Now if I do -2, we've got -2 squared over, it would help if I showed you this. So we get -2 minus 1. So that's going to be 4 over -3. So what is that, like -1 1/3? 3, 4, yes. So -1 1/3. So again, if you come over here and you look at this, you go over, we said we go over -1, we go down -1/2. So it's like right there. And then we go over -2 and we go down -1 1/3. So it's like right there. It's going to be right along in here. And you can continue plugging and chugging to find your asymptote, or to find the points that it looks like. Again, we could do the same for 2 and 3. You would just plug that in, and if you do, you're going to find that it starts to take shape like this. So hopefully that makes sense. That gives you all 5 of those things that you need to do. If you can do those 5 things for your rational function, that will make your life a lot easier, because it's like 90% of the work is done if you do those 5 things. If you have any questions, let me know. Otherwise, we will see you next time.